Okay, so let's learn about how scientists use measurement in lab situations and for science. So, how much, how long, and how many? Our essential question is going to be, why do scientists use a standard measurement system? And so, scientists do have units across the world that they use basically so they can communicate better with each other. And we're going to learn more about that. Okay, measurements must have a standard. What exactly is a standard? A standard is an exact quantity that people agree with to use for comparison. So whether we're talking about someone across the world in Russia or we're talking somebody about in the United States, they both are using the same standard, and so their quantities or their numbers will equate. So a standard means that two people using the same object should get close to the same results. Now, in the past, people used their body parts to determine the length of something. So let's say the king had a 12-inch foot. Well, then a foot would be 12 inches. But what happens if another king came, into power and his was only 8? Then a foot was 8 inches. And so those were not good standards because they didn't have any true validity. They changed. People would use their feet to measure distance. So this is the how, of course, the term foot came about. Now we know, of course, that a foot is 12 inches. But again, people would just measure out and get estimates. There was never a true value to the measurement. Now, the English system, which is, of course, what we use, is very confusing because it has so many different values. America is the only country that still uses the Old English system. And so therein lies a big problem. Scientists don't particularly care for the English system. Scientists need exact uniform systems of weights and measurements in order to be able to communicate with each other. So how did the metric system come about? During the 18th century, scientists measured the distance from the Earth's equator to the North Pole and then divided it into 10 million parts. That became the length of the standard meter. We have exact and inexact numbers. Hopefully you've learned about this in math class too. Exact number is a number with no uncertainty. So we have a dozen donuts, 7 students, 10 fingers, 10 toes, exact numbers. Inexact means that it does have a level of uncertainty in it. And those are anytime measurements are made and results or data are taken. So the height of a student, the temperature, all of those are inexact. There is a little bit of uncertainty. Precision and accuracy are also important. Accuracy tells us how close a measured value is to the actual or to the true value, where precision tells us how close the measured values are to each other. So let's do some examples. Here we have, if we look at our dartboard, we have all of the darts, basically in one area, but they're not near the bullseye. So we have low accuracy, but high precision. Here, they're scattered all around the bullseye. Here, we're fairly highly accurate because we're close to where we want to be, but we're not precise because they're all in different areas. And finally, high accuracy, high precision. They're all close to the true value, to the actual value, and they're all close together. Now, there are several systems of measurement throughout the world. There's the English system, which of course we use, the metric system, which is used worldwide, and then the SI system, or the International Science System, which is used by scientists. And when we're talking about the SI system, we have some base units: meter, kilogram, seconds, kelvins. You'll learn more about moles in chemistry and amperes and candelas in physics in high school. So let's focus on meters, kilograms, and seconds. Now, With those base units, we use prefixes. And of course, we've learned about prefixes. We know that they can change the meaning of something. They do the same thing here. Kilo means 1,000 times something. Deci, 1/10 of something. Centi, 1/100th of something. Milli, 1/1000th of something. And so here we can see we have 100 centimeters, which is a meter. We have 1,000 milligrams, which is a gram. So those prefixes do the same thing for us like our typical ones do. They just change the meaning. Now, when we're talking about length, meter is the basic unit of length. If we're talking about mass versus weight, remember, and you guys are good at this, mass is the total quantity of matter. Weight is the measure of the force of gravity. So for instance, if you weigh 60 kilograms on Earth, will you weigh more or less on the moon? And why? I'm going to ask this question in class. So how much does this astronaut floating in space weigh? What is his mass? These are all things that we've talked about already. And again, you guys are really good at the mass versus weight discussion. But the base unit for mass is a kilogram. Again, note that that prefix is there. It's kilogram. So it's 1,000 grams. 10 pennies weigh about 1 gram. So 1 gram is, 1/1000th of a kilogram. Again, let's remember those prefixes, and we're going to work on converting between them as well. Now, when we're talking about measuring area and volume, area is the extent of the surface. Volume is the amount of space that that object takes up. So if we're talking about area, we're talking about length times width. So we're getting a squared number, square feet, square centimeters. If we're talking about volume, the total space, we're talking three-dimensional, and it becomes cubic. So length times width times height, side times side times side. So we're talking about cubic feet, cubic centimeters. Notice those exponents. For area, we're squared. Volume, we're cubed. Now, when we're talking about volume, a cubic meter is a pretty large unit of volume, 3 feet by 3 feet by 3 feet. And so what we typically use when we're talking about volume in science is we talk about cubic centimeters. Now, the great thing about 1 cubic centimeter is that it is equal to 1 milliliter. So we have this structure of volume where we're length times width times height, but we're equating it to a liquid volume. Okay, and of course, when we're talking about SI units, they are new to us, so the best way to understand them is to use them in everyday life. Okay, now when we want to measure volume of an irregular object, one thing that we're going to use is water displacement, where you have water to a certain mark. You add the object, you see what the water rose to. That actually gives us the volume of an object. For instance, this dinosaur, we can't measure length times width times height. It's an irregularly shaped object. So how would we figure out the volume? Drop it in a graduated cylinder. Another unit of measurement is temperature, how hot or cold an object is. There are several scales for this. There's Kelvin, Celsius, and of course, Fahrenheit. The most common ones in science, what we're going to be using in the classroom, is Celsius. So if we do some comparisons here, the freezing point of water is 0 Celsius, 32 Fahrenheit, 273 kelvins. Room temperature is 22 degrees Celsius, 72 Fahrenheit, 295 Kelvin, and of course the boiling point of water, 100 degrees Celsius, 212 degrees Fahrenheit, and 373 Kelvin. So just some comparisons. But again, in the lab, we're going to be using Celsius most of the time. Okay, I hope you learned a little bit more about measurement, and we're definitely going to do some practicing with converting from different units in the classroom. Thanks. See you soon.